All right, welcome everybody. Thanks for coming to check out the oaxColor extension report out. We're gonna talk a little bit about the extension and do a little bit of a virtual demo, a PowerPoint demo with a few of the new features that we're adding for the 1.1 release. So my name is Ben Hofer. I'm the chairman of the oaxColor extension working group. And Rajiv's here as well. He's going to be talking about the cut pattern, and he's been an active member contributing code as well. Yeah, once again, do a little overview of oaxColor, a little background in case some of you are not there for the 1.0 release or unfamiliar, and then we'll just go right into the two topics. Okay, so multi-patterning. So in more advanced nodes, there's the use of what's called multi-patterning technology, or MPT. It's also referred to as coloring. And the goal is to enhance feature density. And so you'll see below, here's an example of the NAND gate library where maybe some coloring would be done. So instead of a single exposure for a metal layer, this coloring capability, what it does is it allows multiple masks to be made for a single layer. So for example, here, if you had an M1 drawing, M0 drawing, something like that, and on the left side, you'll see just a single mask, right? It's all one layer. But on the right side, you'll see it's actually drawn as three layers in the EDA tools, and then three separate masks are made. And then that way you can get the feature density much tighter. So that's the idea. So the problem, not really a problem, but the issue is in OA, there is no formal definition for how this is implemented in design. So in 2012, Cadence authored a specification document called Data Model Specification for Multi-Pattern Technology Support. And they released this and provided it to spec out how this could be implemented in OA through app defs. Okay. And so I believe it was last year, the working group that I'm involved in released an extension to read and write coloring information according to that spec. So it's a C++ reference implementation with scripting support through OA script in Python and Ruby. And it's developed with a similar style as some of the other popular extension frameworks, such as oaxPop or oaxCon. And so it's quite very much in the same style as those. And the goal of this entire thing is to standardize how OA users interact with the coloring information in design in an accessible and extensible API. So you can use this, you can extend this API for your needs. And so far the 1.0 has been released. The next steps, we're working on a 1.1 release. All the feature set is there. We're just wrapping up some documentation and doing a little more testing, and we want to put some good examples out there as well so that it's clear how to use it. All right, so let's dive right into the two new features that are being added in this next release. One of the bigger ones is the hierarchical instance color shifting. Now, we haven't seen much use for this, but that doesn't mean that it's not used elsewhere. And the main idea is, you see below, we have three blocks, right? So you have block A, and you may have different instantiations of block A and the routing to it, or however it's connected on the next level may have different coloring. It may not always have the same coloring, right? So you see block A is here on the left, and then in the middle, you'll notice that A1 is shifted to line up with the green. Let's call maybe the green is mask color 1 and the red is mask color 2. So we can shift the coloring on a specific layer on the instance, and then that will allow it to connect correctly with the right masks. Same thing with block C. You can see the instance shifting is cumulative, meaning you shift A1 by 1 and you shift B1 by 1. Well, A1 is going to essentially be shifted twice at the top level. Okay, that's the main idea. And so just a little look at the API for this. So yeah, 1.1 is when we're going to be adding this new support. We have what's called a layer shift cache, which is, I think it's word for word what is in the Cadence spec. And it's used to support indexing of all permutations of shifting allowed on the technology. So in a given technology, you'll have a number of layers. Let's say you have 3 or 4 layers that have color shifting or MPT technology support. This layer shift cache, you can think of it like an index-based lookup for every possible shift combination on every layer. It's just a way of storing, one thing the spec tries to accomplish is very low memory footprint, right? So essentially the instance shifting is a single integer app def that's placed on an instance that is indexed into this table to get the exact layers that are shifted and by how much. So in the API, this is going to be documented in the comments, but the cache, you need to set this cache on the block prior to applying any sort of shift to an instance. And then there'll be functions provided to derive this and set the cache, right? So you can generate what that index table, that layer shift cache should look like from the OA tech, and then apply it to the block, right? Or you can read it directly from the block if it's already a design that's been shifted. And then, of course, functions to get and set a shift value per layer on a specified instance. So here you see some of the functions below. You have the set layer shift cache, has layer shift cache, and then you can also get the layer shift cache on an OA block or an OA tech. And so it is up to the user to manage this. For example, if you go to try to set inst layer shift using the functions below on a given instance and you haven't set that cache, or perhaps the cache is invalidated if the technology has changed, it's undefined results, right? It's likely going to throw you an exception. It will throw you an exception in that case, and you'll need to make sure you deal with this. So it's a very low-level API. We're not managing and tracking like changes to the technology and how that will impact the existing coloring on the design if you're doing those kinds of things. All the tools are here in the toolbox, but that API would need to be extended for your specific needs. Okay, and then once again, reset inst layer shift. Actually, that is incorrect. It should just be OA inst. You wouldn't provide a layer that resets all of the shifting for every layer on a given instance, and the get inst layer shift will get the shifting on a given layer. So last one is it's sort of like a virtual demo. I just want to show some code examples I've drawn in an EDA tool. That example that I've given below, block A, B, and C. This one has 3 colors instead of 2, and so you see the red, green, and the yellow. I think I had this on Metal Zero. And so on the first, on the very far left, you'll see this is bad. I mean, we have all the 3 masks connecting to each other. This is not what we want, right? And so on the bottom left, you'll see we first create an MPT object, open the design in append mode, and get the top block, and then we get the layer through an OA layer find. This is in Ruby. I know Python is more popular. I'm more used to Ruby, but it should still be readable. It would be basically very similar commands in Python. And then just to be sure, I create the cache from the tech, right? And then I want to check, does this block have a layer shift cache? If it does not, I put a little comment here saying setting layer shift cache for design and print out the design. And then I set the layer shift cache that was derived from the tech on the block. Okay, and then finally I find the IA instance. I didn't label it in here. IA is the instance of this guy here. And I just do a little printing. Here you can see I'm doing an inst kit name, which is IA, and I'm getting the inst layer shift. You can see it's printing out. It has a shift of 1 after applying that shift. And then I save and close the design. So after that process, you'll see now this is getting a little bit closer to what I want. I have these lined up, but there's still an issue with the outermost block. So this is block C at the very top level, and the instance of the intermediate level of hierarchy is IB, right? Instance of block B. And so it's very similar concept. Just open it up, create a new MPT object, open up the block C, get the IB instance, and I'm also doing a shift of 1 here. It's a little trivial, but it's trying to show that now once I do that, you can see the result is cumulative. We have everything lined up and correct on these, let's just call it mask color 3, right? If you shift on a 3, for example, it will loop around and go back to mask color 1. And then save and close the design, and then that's it right there. So that's an example of the instance shifting code. I'm going to have Rajiv cover the cut pattern shifting. One thing I do want to mention that I forgot to say in the beginning was that with this 1.1 release, we will be complete to the spec. So the entire spec will be implemented, and we wouldn't expect to really make any additional changes unless we find bugs or any issues like that.
Thank you, Ben. So I'm just going to talk about this cut pattern coloring. So for the multi-pattern technology, when you have a standard via with many number of cuts, the coloring also has to be applied to those cuts to form a pattern. So the most optimal pattern is actually dependent on the technology spacing rules. There are two patterns that are allowed or mentioned in the spec document. One is a checkerboard pattern, which is the most ideal and the default pattern. But sometimes there may be color spacing rules that may allow another pattern called an alternating row pattern to be specified. So this on the left, you can see this is a via layer which has two mask colors, and the checkerboard pattern is applied. On the right, you have the same via layer with two mask colors, and an alternating row pattern is applied. So this cut pattern coloring can be set on the technology or OA tech, but it also can be specified on the OA via definition. So on the right here, you can see there are the cut pattern is actually an enum class in C++, with the two supported patterns, and there are setter and getter functions to set the cut pattern to apply the cut pattern coloring either on the OA tech or the OA standard via definition. So the first one is doing a set cut pattern coloring on the OA tech. The second one is the get cut pattern coloring again on the OA tech. And then the next two are on the OA standard via definition. So this is just a, a representation of how the cut pattern coloring would appear on a via layer, which has three mask colors. So on the checkerboard, if you see, it's the pattern is more like a checkerboard where it's like the zigzag pattern. On the right, you have the alternating row where the mask colors are per row. So the blue is on the first row, the red is on the second, and then the gray is on the third row, and then it keeps alternating. So these are some code examples of how how the API can be used to set the cut pattern coloring. In this first case, we are going to be setting the cut pattern coloring at the technology level. So on the leftmost screenshot, if you see here, it's there. I have two via arrays. On the bottom, it's a via array on a via layer which has three colors, and the top is a via array of a via layer which has two colors. By default, this is the checkerboard pattern, which comes up in the tool. Then we do a code where we create an instance of the MPT. We open the tech, and at the tech level, we are setting the cut pattern coloring to alternating row. Once we do that, then on the right snapshot, you can see for both the via arrays, the one with the two mask color layer and the one with the three mask color layers, the alternating row pattern has been applied. This is the example where we are setting the cut pattern coloring at the via definition level. So the OA standard via definition. So here, before I apply the code, I have four via arrays instances, and all of them are the checkerboard cut pattern. On the bottom, I have a via layer which has three mask colors, and on the top, I have a via layer which has two mask colors. But by default, they are all checkerboard cut patterns. Then I do a code where I open the block, the design and the block, and get all the vias in the block. And here, what I'm doing is I'm for um, every other via array, I'm changing the pattern to a alternating row pattern. So when I run through that code, then on the right side you can see there is for the first and the third instance, the alternating row cut pattern got applied, and the other two remain as the checkerboard cut pattern. So the bottom again is for the via layer with three colors, and the top is the via layer with two colors. So this is how the cut pattern coloring can be used with this API. So next I'll turn it back to Ben.
Okay. Yeah, I think that concludes what we wanted to talk about today. And yeah, I think now it's time to open up for questions.